signal also tells how far this event was. Okay? How far. There's one more thing, actually many more things which we can deduce, but another thing which we can deduce from the data. We had two detectors. I was telling you guys at the beginning that yes, the gravitational wave detectors are ears, it is sensitive to every direction. But if you have two detectors, you can actually use the time difference between the arrival time of the signal between the two detectors to triangulate and tell something about the direction where the signal came from. Actually, so it's using our timing distribution system. You know, time is the second most important data in LIGO. I keep telling everybody gravitational wave data is the most important, but we collect everything versus time. So that's very important. So they use the time difference observed between the two detector sites to tell something about the direction. And you have two detectors when you triangulate, you get a circle on the sky. It's not exactly that the gravitational wave detector is sensitive to every direction in the same way. So there are little blobs, and it looks like this directional sensitivity looks like actually a peanut. So you're getting more like a banana and not a circle on the sky. But if you had a third detector, you could actually locate much better. You know, it's not really great in terms of an astronomy sense, but astronomers working on it, and even we are working on it at Columbia, and giving some strategies how to follow up for a possible, if possible, optical event which happened coincidentally with these detections. So SkyMap is also a product of the data, of the signal, the waveform which we detected. Okay? And I'm not sure whether you guys listened and heard the second event. How many of you guys have heard about the second announcement? All right, we haven't had a second announcement because we see it only once. I do not believe it. But we were actually ready to put out and not make the announcement, but we wrote the paper already when the second event came. We were already convinced because it was really, really a big event. Just sometimes the universe gives you what you are hoping for, and you got locked faster on your side because something happened, and you happen to be online and actually collecting data at the same time. But we did have a second event which was very, very high significance, also above 5 sigma. Some of you guys have heard these sigmas and significance for a given detection. That's like the benchmark. And that looked like this. This is, you know, the first one we call the Rosh Hashanah event sometimes because it happened on Rosh Hashanah. This is the Christmas event. It was Christmas in the US, but it was on the 26th in UTC time, which would be because it was right the next day. So this is the way it looked like. If you guys looked at the simulation, these were a little bit smaller black holes colliding and mergers, so the signal is not as big. However, it lasts very long because they are a little bit lower mass, but it means just like, you know, I was telling you, black holes, when they merge at a lower frequency, and then we reverse signal. Neutron stars, we would not necessarily see their mergers unless we really, because that happens at higher frequency, unless we really, really work on the sensitivity of the detector. So this is a bit lower mass black holes, and they merge at a bit higher frequency at the end. So they stay in the band a bit longer. So we have a longer signal to work with. All right. So I want to show that to you, and oh, okay. Did you guys hear that? Yes. You guys heard that? Okay. So it was but then there was a bit of a shift, so you guys could hear it, and you could hear a really nice long chirp. It stayed in the band quite a bit longer. Okay, so of course when we analyze the data, and I was not lying, cheating, I don't know. I did not tell you guys why we also wrote that paper, because we found a third thing, which is not a detection. Don't say that we have a third detection, because we can't say that. We say it's around 2 sigma. Not very close enough to that 5 sigma, which we would love to hear. It's around 2 sigma. And this is a very probable. We call it this event candidate. This actually happened a year ago, +1, -1 day, or whatever. It was October 12th, a year ago. That's my son's birthday, actually. So, yeah. When we wrote the paper on this came in the meantime, a month after the first detection. So we knew from the beginning on that this is very probable, that this is a signal. This is still what LIGO says. I say as well, you ask any LIGO person, this is a very good event candidate. It's so good that we know not to that good accuracy, but we know nearly everything about it. So this is the timeline, and people ask us often that do we have anything else in the data? If we do, which we collected between September and January, if we do, it's not obvious. So at the moment we don't think so, most likely not. Okay. So these are the 3 events. 2 are confirmed, and there is 1 which is a candidate. This is more asymmetric, it's smaller black hole, and another larger, but it's not as large as the first 2 which gave the very big signal. So, but we can tell about where they came from also. So we have our bananas, not making the astronomers very happy, because still too much area to follow up, but they know something, that other detectors will join us. It's not only 2 LIGOs in a couple of months. After LIGO we studied Virgo, which is another gravitational-wave detector in Italy. It's the European detector. Will also join us, and when we have 3 detectors, we are more likely to be able to tell more about the direction where a given signal came from.